Welcome to a short introduction to the maxon encoder families. The maxon encoder portfolio has grown a lot over the last few years, and still new versions are added. What are the main distinguishing features of the different families? For more information about encoder signals in general, please refer to the tutorial about incremental encoder selection rules. In the maxon catalog, you find encoder with funny names such as gamma, MR, easy, quad, heddle, TSX, EMT, ENC22, mile. Most of them are incremental encoders, but there are also a few absolute ones. And you can classify them according to the underlying physical principle into magnetic, optical, or inductive encoders. The most important magnetic encoder families run under the names of MR and easy, the easy in different types. The main optical encoder consists of the tiny Rio and the larger AEDL and HEDL/HEDS. The only inductive encoder type is the mile. There are some magnetic and optical incremental encoders for special application situations. The gamma is a radiation hard encoder. The quad serves for motion detection. The TSX encoder for applications with through shafts. And there are encoders with tiny outer diameter for the smallest maxon motors. The easy encoder can also be configured as a single-turn absolute encoder. And the EMT stands for a multi-turn absolute encoder. Some of these encoders are also called ENX encoders, where the X stands for the possibility of selectable encoder resolution and cable configuration. In the following, let me give some background information for the most important of these families, shown in dark colors. We start with the MR. MR stands for the magnetoresistive principle that is used in the sensor for channels A, B, and the index. MR uses the fact that in certain thin film materials the electrical resistance changes with the relative direction of current flow and magnetic field. The multipole magnetic pole wheel mounted on the motor shaft creates the necessary magnetic field changes at the sensor positions. The MR sensors are designed to create a sine and cosine type signal for each magnetic pole. These signals are further processed to generate the typical rectangular incremental encoder pulses. The resolution depends on size and interpolation. The low resolution version creates one encoder pulse per magnetic pole, simply by rectifying the sine and cosine signal. The high resolution versions use an ASIC for signal interpolation and as a line driver. Due to the interpolation and other tolerances, the MR encoder has a lower accuracy than the optical encoder. The angle deviation from the true mechanical position can be as high as several degrees, depending on diameter. This is about 5 to 10 times less accurate than optical encoders. However, it is still the perfect encoder for many standard applications that don't require excessive precision, in particular in combination with gearheads or other drive mechanics that exhibit backlash and elastic behavior. The MR encoder exhibits a small size. Generally, its housing has the same diameter as the motor, and the motor length is increased by just a few millimeters. MR encoders can be found on older maxon motor families. The easy encoder is a magnetic encoder as well. It is based on two pairs of analog Hall sensors integrated on one chip. The magnetic target is designed very easy as well. It's just a magnet with one pole pair mounted at the end of the motor shaft. As on the MR encoder, the sensors produce a sine and cosine signal that are further processed and interpolated in the encoder in order to create the incremental encoder signals. The characteristics in terms of accuracy are similar to the MR encoder discussed previously. It lies around 1 mechanical degree. I'd call it medium accuracy. The interpolation and hence the resolution can be programmed to values ranging from 1 to 1024 counts per turn. The easy encoder has a very robust tiny metallic housing of diameter 10 or 16 mm. From the point of view of possible applications, the easy is very similar to the MR encoder as well. The main differences are the mechanically and electronically more robust design and the wider range of possible counts per turn. The easy is the standard encoder on more recent small maxon motor designs. A remark: the unique rotor position signal within one motor turn allows to generate absolute encoder signals. That's the easy absolute single turn encoder. Optical encoders are the most accurate encoders in the maxon portfolio. This is due to the high resolution and direct sensing without interpolation. In optical encoders, the light of a LED passes the slits in a pole wheel mounted on the rotating motor shaft. The light is detected by phototransistors, directly producing the high and low states of the encoder channels. The smallest optical encoder in the maxon portfolio, the Rio, uses a reflective optical principle and signal interpolation to achieve a very high resolution. Some of the most common encoders on small motors are the HEDL and HEDS encoders. They can be found not only on maxon motors. The standard HEDL and HEDS encoders used at maxon have 500 counts per turn, with other options up to 1024 counts per turn. The HEDS is the version without line driver, the HEDL with line driver. The AEDL has an even higher resolution of up to 5000 counts per turn. Optical encoders are the best in class when it comes to accuracy and often also resolution. However, they are larger in size than many other maxon encoders, which makes them not very suited for the smallest motors. The high resolution in combination with the high accuracy results in a perfect match for high precision positioning and the feedback of very low speeds. Backlash and elastic properties of gearheads counteract the accuracy. Therefore, optical encoders of highest resolution are best in direct drive applications with powerful motors. The mile is the perfect encoder to be integrated into flat motors. It contains all the electronics, including line driver, in one tiny chip. The mile is based on an inductive principle. A high-frequency signal is transformed onto two pairs of pickup coils. The transition is modulated by a multiple metallic structure on the rotor. Each section of the metallic target induces sine and cosine modulated signals in the pickup coils. An Arcus tangents operation gives the rotor angle. Further signal treatment includes an interpolation and the production of the rectangular encoder pulses. An adjustment process allows to correct the signal states width by means of a lookup table. For the mile on flat motors, there's no index channel possible. The resolution of the mile lies in the range of 256 up to 6400 counts per turn. The larger the motor diameter, the higher the maximum number of counts. The large diameter of the flat motors in combination with the lookup table correction results in a rather high accuracy. The mile encoder on flat motors can be used for high and low speed control within the specified operating range of the flat motors. Positioning can be done with quite high accuracy. While the easy absolute encoder can only give absolute position feedback within one turn, the EMT is also capable to keep track of the number of turns. The feedback within one turn is done similarly as on an easy encoder with an arrangement of analog Hall sensors. An application-specific integrated circuit transforms the signals and creates the absolute position signal outputs. Additionally, the EMT features a self-powered rotation counter for monitoring the motor revolutions in a non-volatile memory. This multi-turn counting works even when not powered, thanks to the Wiegand wire technology. Hence, no battery or gear is required. The resolution within one turn as well as the number of countable turns are very high, 70 or 16 bits respectively. The small size of just 22 millimeters makes it unique on the market. The 22 EMT is available with one of the standard interface protocols for absolute encoders, BIS-C or SSI. Typical applications include high-precision positioning without the need of time-consuming homing procedures. The high resolution can typically be used for direct drive applications without gears. After learning more on the main encoder families, let us have a short look at the specials. The Gamma is a low-resolution magnetic encoder for brushed motors. It operates with digital Hall sensors. It is to a certain degree insensitive to radiation and can be used in applications with exposure to X-rays or other ionizing radiations. The quad encoder gives just 4 states per turn. It's rather a sensor for supervising purposes. Does the motor rotate and in which direction? It should not be used for feedback, and it does not work with maxon controllers. There are special tiny magnetic and optical encoders for the 4, 6 and 8 mm motors. They work in a similar way as the larger magnetic and optical encoders, however with reduced resolution. The idea of the TSX encoder, be it magnetic or in future optical, is to provide an encoder that is not mounted at the motor's shaft end, but the encoder module can be added on the side. For instance, this allows for hollow motor shafts, as can be found on frameless motors, such as the maxon dynamic torque. Of course, a suitable target must be added on the motor, such as the brownish magnetic ring in the picture. The ENX22 is a very old optical encoder with limited resolution. You can find it only on some older medium-sized maxon DC motors. A short summary focusing on the main incremental encoder families. The MR and easy encoders are the first choice. They can be found on many maxon motors and fulfill the feedback requirements of most applications. These encoders are also perfectly suited to be used in combination with gearheads. On larger motors and for very precise feedback, the HEDS and HEDL encoder might be best suited. The high-resolution RIO and ADL are primarily intended for high-precision direct drive applications. The mile encoder is the standard for feedback on flat motors. And the EMT provides high-precision, absolute multi-turn position feedback for positioning without the need of homing. That's it. A short introduction to the maxon encoder portfolio.